Welcome back. We're at NASA's Jet Propulsion Laboratory in Pasadena, California, and we're here to talk about the InSight mission. The InSight mission has a date with Mars come Monday, November 26th. It will be landing on the red planet. That landing takes place at about noon Pacific time, 3 p.m. Eastern, with commentary broadcast live about an hour before that. We're going to talk to the science team now, the science panel, and they are going to explain to us how the InSight mission will be detecting the vital signs of the planet. We have instruments that we'll be placing on the surface of Mars to tell us more about how Mars formed and, in fact, how all rocky planets formed. I'm going to begin by introducing Dr. Lori Glaze. She is the acting director of NASA's Planetary Sciences Division.
Great. Thanks, Veronica. I'm excited. I know you are too. I was already excited when I got here. And then sitting through the mission briefing this morning, I'm even more excited than I was before. How exciting. 5 more days and we'll be there. We'll be landing yet another planetary mission on the surface of Mars. Each of the planetary missions, each of NASA's planetary missions, is on a quest to answer important questions about how our solar system formed and how it changed over time after it formed. We've sent lots of different missions to different worlds and different corners of the solar system, and they're each trying to answer that same question in different ways, different types of observations at different types of worlds. Some of the most fundamental questions that we have about how our solar system formed and how it evolved have to do with how did the rocky planets in our solar system form and evolve. The rocky planets, Mercury, Venus, Earth, Mars, and even our moon. Each of them are similar. They're rocky planets. Some of them have atmospheres, and they have structures that are similar, have similarities and differences. If I could have the first graphic, this graphic actually shows a cutaway of Earth and Mars and the moon. And what you can see inside of each of these rocky planets is that they have at their center a core. And that core can be solid or it can be molten. And then outside of that core, there's a middle section that we call the mantle, which makes up the bulk, most of the mass of each of the rocky planets. And each of those rocky planets is covered with a thin crust. What we really want to know is what are the similarities? How are they different? How are they the same? What are the relative sizes of those different parts of the interiors of those rocky planets? The different sizes. Is the core, is it molten or is it solid? Is that the same for each of the planets? That we need to know. Most of the missions we've already sent to Mars are either making observations from orbit, getting at the surface conditions, trying to understand what's happening within the atmosphere on the surface, sending landers and rovers, again, just scratching at the surface to understand that surface environment. If we want to understand what the insides of these rocky planets are like, we have to make different kinds of observations that can really penetrate down into the center of the planets. The types of measurements we make on Earth are things like seismic measurements, understanding the level of seismic activity, thermal measurements, heat flow, understanding the amount of heat that's getting out and released from the planet. We do this on Earth on a regular basis. We've actually even done these types of measurements on the moon. With the Apollo program, we had astronauts that brought these types of experiments and deployed them on the surface of the moon. But if we want to make these kind of measurements at Mars, we haven't sent astronauts to Mars yet. They will be going at some point in the future, and a lot of what we're doing is in preparation for that. But if we want to do this on Mars today, we have to do it robotically. And so with that, I'm going to introduce Dr. Bruce Bannert, the PI for the InSight mission, to tell us a lot about the science. And when I go off the stage, I just want to say, go InSight. Yeah.
Okay, so InSight is going to Mars to study the deep interior of Mars in order to understand how all the planets formed. I mean, we know a little bit about how planets form. They accrete from a solar nebula. As they accrete, they get hotter and hotter, both from the energy of the impacts and from radioactive decay. And then they melt and transform from sort of a uniform ball of meteoritic material into the diverse planets that we see today. Some of those planets are a little bit harsh. Venus is hot enough to melt lead. Mercury has a sun-baked surface. Mars is pretty cold today, but Earth is a nice place to take a vacation. So we really like to know why one planet goes one way and another planet goes another way. And those answers are in the details of the structure that's formed very early in the planet's history. On Mars, that structure's been preserved for over the last 4.5 billion years, whereas on the Earth, where we actually can study it pretty easily, that structure's all been sort of scrambled up, both by plate tectonics, by mantle convection, and so the evidence of the very earliest processes has been wiped away on the Earth. We want to go to Mars to do that, to study those processes, to look at how those processes came about very early in the planet's history. The main way that we're going to do that is with seismology. And the way we use seismology, when you want to study something, the first thing you want to do is look at it. And the way you look at it is you bounce light off of it, it goes into your eyes, and your brain can interpret it as an image and see a 3D image of what you're looking at. If you're looking at the center of a planet, light doesn't help you very much because it doesn't go very far through rock. So what we do is we use seismic waves, vibrations that are created by earthquakes on the Earth, Marsquakes on Mars, also meteorite strikes. Anything that starts the planet vibrating sends those waves through the planet. If I can have the first animation. This shows a seismic event on a planet, and it's showing the waves that travel through the planet, the blue P waves, the red S waves. And these waves travel through the planet the same way light would travel through a lens or something like that. And so a Marsquake is sort of like a flashbulb that goes off and illuminates the inside of a planet, and our seismometer is the eye that we use to see what's inside the planet. And by looking at those seismograms that you've seen on television, those wiggles on a graph, scientists have learned how to interpret the shape of those waves, the time which they come in order to understand the medium through which those waves travel. We can figure out what the inside of the planet's made out of. We can figure out where the different boundaries are between the rocky mantle, the iron core, and so forth. And so a seismometer allows us to look deep into the planet and understand the detailed structure. We also have a few other instruments, a few other investigations on this mission. One is a radio tracking experiment. We actually track the planet very precisely. And in particular, we're tracking the North Pole of the planet and watching it wobble as the planet rotates. And the wobble at North Pole is tied to the interaction between the planet and its core. And by looking at the wobble, its size, its frequency, how fast it's wobbling, we can actually determine the size of the core and what it's made out of. And that's very critical in terms of understanding the history of the planet and the way the planet is operating today. And finally, we have a heat flow probe. It's a very interesting device. Tilman Schwann's going to tell us a little bit more about it later. It penetrates down into below the surface, about 10 to 15 feet below the surface, and measures the temperature as you go down, and we're able to use that to extrapolate to the center of the planet and understand how hot it is in the middle of the planet and how much heat is coming out of the planet. And that heat is what actually drives the geology at the surface. And in particular, it drives tectonics, which is the quake motion of the planet, and it drives volcanism. And here to talk a little bit more about these geological processes and how InSight's going to illuminate that is my deputy PI, Susan McCarr from JPL.
All right, thanks, Bruce. All right, well, every geologist and geophysicist that I know likes to climb mountains. And if we could have the first graphic. Most of us aren't lucky enough to be able to climb Mount Everest. However, some of us are privileged to be able to study the mountains on Mars. And as you can see, the mountains on Mars actually dwarf Mount Everest. These volcanoes are not only the tallest mountains, but they're the tallest volcanoes in our solar system. These volcanoes actually formed billions of years ago on Mars, and when they formed on Mars, they actually covered about a quarter of the planet. You can see Olympus right here, and you can see this whole volcanic region that formed early in the history of Mars. And if we go to the next graphic, we can talk about how these volcanoes formed. For me, really the most compelling thing about volcanoes is the fact that they are really conduits from material way deep in the planet to the surface. Not only do volcanoes spew lava on the surface, they also release gases into the atmosphere. They release things like water vapor, carbon dioxide, methane, all the things that we need to actually form an atmosphere. So the best analogy between the volcanoes on Mars and those we have on Earth are actually places like Hawaii. So Hawaii is an example of a hotspot volcano. So material from deep in the mantle, actually at the core mantle boundary, rises up in a plume over tens of millions of years. And as they come up and intersect with the crust, it forms volcanism at the surface. Now, on Earth, we have plate tectonics. So when that plume comes up and hits the surface, it actually is intersecting a conveyor belt. The plates are moving slowly across that plume. And so one volcano forms, and it's carried off downstream. So actually at Hawaii, there's we see those few volcanoes at the surface now above the ocean, but it really is just one of a series of volcanoes, dozens and dozens of volcanoes that are now under the surface of the ocean. On Mars, we don't have plate tectonics. So when that plume comes up and hits the crust, it stays there in one place. And so instead of making a line of volcanoes, we have a series of volcanoes. And you can see this complex of volcanoes that was formed above a mantle plume early in Mars's history. The thing that we're really looking forward to for InSight is being able to go back in time. Mars formed these volcanoes in its first couple billions of years at a time when there was a magnetic field, when there was liquid water in the surface, all conditions that we think are important for habitability of a planet. For InSight, we're going to learn about the interior structure, the core, the crust, the mantle, the heat sources in the interior. And with that information, we'll be able to better understand how the interior of the planet affects the surface environment on rocky bodies, not only on Mars, but in our solar system and on other rocky bodies around other stars. I personally have been waiting for this information for decades, and I'm super excited to start getting this lander on the ground and start taking this data. Up next to tell you about some of the instruments that will acquire this data for us is Philippe Laudet, and he'll be telling us about the SIZE instrument. All right.
Okay. Good morning. My name is Philippe Laudet. I'm working for the French Space Agency, which is called CNES, so sorry for my French accent. And I have been the project manager of the SIZE instrument for now more than 7 years since the pre-selection of the Discovery program in 2011. So as you have understood, InSight will make measurements of quakes and meteorite strikes on the surface of Mars, and for that he will use a seismometer SIZE, which is provided by the French Space Agency CNES, and also by IPGP, who is a French laboratory for geophysics research, and it's our French PI for SIZE, Mr. Philippe Laudet. And as you can see, I don't know where the film is. Sorry, I didn't see the screen. Thank you. So this instrument will be deployed exactly on the surface of Mars in order to have better accurate measurements of the seismic waves. And the major engineering challenge we had due to that position on the surface is to protect the instrument from thermal variations and also from the wind of Mars, which is very aggressive for that kind of instruments. So you have a protection on the seismometer itself, and another one is the wind and thermal shield, which is being deployed on the film, which is deployed in a second time by the same robotic arm, exactly on the seismometer. And there is absolutely no mechanical contact between both, because the windshield will move with the wind, but not the seismometer, of course. Okay, and as you know also, we are not the only instrument on the surface. We have another one, which is a German one, HP-Cube. And I leave the floor to Tilman Spahn, who is going to talk about HP-Cube. And I tell you goodbye, thank you, and see you on Mars next week. Bye-bye.
Hi, greetings from Germany. I'm Tilman Spahn from the German Aerospace Center, DLR, and I am the lead of the heat flow probe, the HP-cubed experiment. DLR has been building this instrument and contributed that to the mission. Now, as Bruce already told you, we're taking a set of temperature sensors down to a depth of 10 to 15 feet to measure the temperature and the heat that is coming from the interior towards the surface. Now, how are we going down? Let's play my first animation. Can we have the first animation, please? Okay, here is the winding mechanism in the mole. We nicknamed that penetrator a mole that compresses the spring. And when the spring is released, it hammers, towards the tip of the mole and then propels it down into the ground. Now we stop the penetration at about 2 feet and take a measurement of the thermal conductivity. And then we continue that. Let's continue the animation. Can you continue, please? And we take we heat the mole and measure the thermal conductivity, and then we continue the penetration and take another measurement of the thermal conductivity and another measurement until we get to the target depth of 15 feet. When we're down there, we will then we'll then activate the temperature sensors, 15 temperature sensors that measure the temperature profile down to a depth of 15 feet. And by combining the temperature increase with the thermal conductivity, we can actually calculate the heat flow. Now, I'm very excited to come here on Friday and then attend the landing event. And then, of course, the experiment, the penetration first, and then the measurement of the temperature and the thermal conductivity and the heat flow, because that will help us decipher, the energetics or the activity of the planet. And this is something that geophysicists have been looking forward, for a very long time. And with that, I'd like to hand back to Veronica to continue the presentation. Thank you very much for your attention.
All right, thank you so much, and stay where you are, Tillman. We're going to bring the rest of the panel back up on stage now to do some questions and answers. A reminder that we will take questions here in the room. We have some media on the phone line. If you're on the phone line, please hit *1. That will put you into the queue for a question. We're also taking questions on social media. Just use #AskNASA and send those in to us. We'll take some during the broadcast. We'll continue to answer those even after we go off the air today. So we're going to open it up here first in the auditorium, and then we'll go probably to phone lines next. So go ahead.
Hi, Ryan Baxter-Vargas again from Spectrum News. You mentioned there's lots of questions that will be answered. What's the number one question you want answered after 2 years?
I think the number one question we want to answer is what's the structure and the energetics of the interior of Mars. And so we have several things that we want to measure. We want to measure the thickness of the crust, the size of the core, the density of the core, and the seismic velocity of the mantle, which tells us sort of what the structure of the mantle is. And those are kind of our key questions, as well as the amount of heat coming out of the planet. So when we proposed this mission 8 years ago, we put together what we call our level 1 science requirements. And these are the things that sort of we promise NASA that if you choose our mission, these are the things that we're going to measure. And that's kind of our list of measurements. And then we also are going to measure how often Marsquakes occur and how often meteorites strike Mars, which is kind of a bonus.
And then a follow-up question, how does all of this help us understand life here on Earth? Will we understand better earthquakes? Will we understand volcanoes better? Will we understand, what kind of everyday parts of our life here will the InSight mission help us understand?
Well, what it really helps us understand is how we got to where we are today. How we got to an Earth that has an atmosphere which is breathable, an environment which is in a temperature range which is comfortable for life, how we have a planet that's covered with water. These are all things that are related to the activity and the structure of the inside of our planet. It's not obvious to everybody, but the fact that we have an atmosphere is because we've had all these gases that have come out of the inside of the planet. The reason we have ocean is because the water has come out from volcanic activity over the billions of years. And so that activity is tied to the initial conditions of the planet. And so we'd like to understand how that happened, how we got to where we are today.
Thank you.
Yeah, and if I could just add to that, life started on Earth, we think, very early on in the first 500 million years, and that crust is almost gone on the surface from the surface of the Earth. Whereas on Mars, that very early crust is still preserved. Those environments that it formed super early in the formation of planets, of our solar system, and so we can kind of go back in time and study those environments on the surface of Mars and understand how the conditions inside the planet created those environments.
Thank you.
Okay, we're going to take one more here in the auditorium, and then I'm going to go to the phone lines, and then we'll be coming back.
Hi, Ian O'Neill for Scientific American and HowStuffWorks.com. Going back even further than that question, how does your assembly of instruments and experiments help explain the origins of planets themselves? I mean, was it, it's almost like a time probe looking back over 4 billion years ago, but how do you hope this will add pieces to that puzzle?
Well, as you said, the structure of the planet is really formed in the first few tens of millions of years after the planet accretes. So we're not going to have much to say about how the planet actually accreted. But once it gets formed from the solar nebula, how it changes from sort of a uniform ball of meteoritic material, which is all kind of the same stuff, into a planet which is differentiated, which has a crust of relatively light rocks, and a very dense core, and a very complex system of transferring the heat from the center of the planet to the surface. These things are all kind of set up very early in the planet's history. And for the Earth, we don't really have any evidence of that system left anymore. What we have is a very evolved system. And so we want to go to Mars to see what that system looked like very early in the process. And so to better understand the physics and the chemistry of how you go from the very, very initial set of conditions with this sort of solar dust and ice that's accreted into the very complex planets that we see today.
And just one follow-up. In regards to meteorite impacts, how many meteorite impacts do you expect to detect with your instrumentation? And yeah, that's the question.
Well, one of the things that we want to actually find out is actually measure how many. We're sort of expecting something of the order of maybe a half a dozen to a couple of dozen in the 2 years that we're on Mars.
Cool. Thank you so much.
Sure.
Okay, we're going to the phone lines next. We've got about 3 different callers right now. We're going to start with the AP. Go ahead.
Yes, hi. This is Marcia Dine, AP. I have a question I'd like both Philippe and Tillman to answer. NASA has a long and rich history of exploring Mars, and as the relative newcomers to this, I'd like to know from both of you what you find so captivating and magical about Mars versus other planets.
I didn't catch everything. Could you repeat to me?
She wants to know what you find fascinating and captivating about us going to Mars and studying Mars.
Everything is captivating first. It's a dream first, and after there is a big challenge because that instrument was supposed to be so sensitive that at the beginning it was just impossible to build. Okay, but we did it with the help of our partners, and particularly JPL. Thanks for that.
Would Tillman like to also weigh in?
Okay, to me, Mars is a planet that is, on the one hand, very different from the Earth. On the other hand, it's quite similar. It's half the size of the Earth, but its environment on the surface is, more Earth-like than, for instance, the atmosphere and the environment of Venus. And understanding the difference between the Earth and Mars, will help us understand the evolution of terrestrial planets in general, and in particular the Earth. And this is what, makes the motivation for going to Mars. And in addition to that, it's easier to explore Mars, than Venus. and therefore Mars is the first target, to do a geophysical observatory like we now do on Mars. So it's timely, and it's very much, justified to do that now.
Okay, our next question on the phone line is from AFP. Go ahead, please.
Hi, this is Ivan Kron of Agence France Presse. You mentioned Marsquakes and meteorite strikes. Can you talk in details about the other possible sources of vibrations that you might listen to?
Sure. So those are the two primary sources of vibrations that we hope to see. We also actually will probably see vibrations due to the interaction of the atmosphere with the surface. So when you have weather on Mars, you have turbulence, that actually is pushing the surface up and down. That will create, on one hand, it creates noise that makes it harder to see the Marsquakes. But on the other hand, when you start beating on a planet like that, it'll actually start resonating at certain frequencies, and those resonances are affected by the structure of the planet. And so we may actually be able to get some information from that. And finally, what we should also be able to measure is actually this is not exactly a vibration, but it's the motion of the surface up and down due to the tidal pull of the Martian moon Phobos. And so every time Phobos goes overhead, it actually pulls the surface up a little bit, and then it goes back down after Phobos leaves. And so we can actually measure that. It goes about a centimeter and a half, a little over half an inch up and down when Phobos goes over. And it turns out that we can actually use that measurement as well to look at the inside of the planet, because how much that goes up and down depends on sort of the elasticity of the planet and whether the core is solid or liquid. And so we'll be able to use that measurement as it happens every 7 hours or so on Mars to probe the inside of the planet.
And if I may, could there be some magma movement at all from the inside?
There could be magma motion on Mars. The area that we're landing in is pretty featureless. I mean, it was a lava plain, but it was put down, several billion years ago. So we're not expecting any active volcanic activity in our region. It's possible that it could be happening somewhere else on Mars. It's conceivable that we could pick that up with our seismic instruments, but we're not expecting it.
Yeah, but we are in a good place. It was about 1,000 kilometers to an area that may have been volcanically active in the last 10 million years. So for Mars, that's yesterday. So we can hope that we might hear some magma deep under the ground, not at the surface, but deep underground.
Yeah.
Thank you.
Okay, we're taking one more from the phone line, and then we'll come back into the room. We're going now to space.com. Go ahead.
Thanks for taking my question. This is Megan Bartels from Space.com. I had a question for Lori. I was hoping you could talk sort of big picture. Why is it that we're so fascinated with Mars and we keep returning with science missions? What is it that really captures us about the planet?
It's a great question, and Mars is an incredible natural laboratory right next door to Earth. And as I was kind of alluding to at the beginning, we really want to understand how we came up with this diversity of rocky planets in our solar system. They're all very different. Each one of them is unique in its own way, and trying to understand how they ended up so differently is a really important question. And Mars is a great natural laboratory. It's right there. It's reasonably easy to get to. We demonstrated that we can land successfully on the surface. We can conduct scientific experiments for long durations on the surface. So it's very amenable to trying to do these types of investigations. And then in addition to that, Mars has another piece of intrigue for us in that it could have potentially had a significant amount of water there in the past. We see lots of evidence of that in the geology. And so we do believe that there was a lot of water there, and it could have potentially been a place where life could have formed very early in Mars's history. And of course, trying to understand how life is or was distributed across our solar system is one of the major questions that we have. Are we alone? Were we alone sometime in the past? And so Mars is really an intriguing destination for that purpose as well, trying to really understand what those conditions were like back 4 billion years ago. Did life actually begin on Mars in that time frame? And if it did, is there any preservation of that left on the surface? Of course, that's not the focus of the InSight mission, but it is the focus of a lot of the other investigations that we're interested in at Mars. And so trying to better understand Mars in that context is important. And then finally, as was alluded to this morning in the mission briefing by Dr. Zabukin, we'd like to eventually get humans back to Mars. We're interested in a campaign now in returning humans to the moon and eventually getting humans to Mars. Again, another destination in our solar system where we feel it is amenable to human exploration and a place where we could go at some point in the future. And science drives our understanding that allows us to get humans to a place like Mars. And so the more exploration we have, the better we understand that environment, the better prepared we'll be to send humans to Mars in the future.
Great. Thanks so much.
Okay, we're going to bring it back into the room here for questions from media, and then from social media, I see our team over here working furiously collecting your questions, so stand by for that. Go ahead with your question.
Hey, Charlie Shelton with CV Weekly. I have a question about the Olympus Mons formation. What is it that is different between Earth and Mars about tectonic motion? Why do the plates not move and allow something so big to build up?
Yeah, so that's part of what we hope to learn from this mission. In fact, for the first order answer is that Mars is a lot smaller than the Earth, and so it doesn't have the same amount of radiogenic material, the same amount of heat that it starts out. So just being a smaller planet, it loses its heat more rapidly. So, you need to have a vigorous convection, a lot of energy inside the planet to drive that motion of plate tectonics. People have proposed in the past that maybe very early in Mars's history it had plate tectonics. Now, we don't have any direct evidence of that. And we don't expect to see evidence of that on Mars with our mission. But it's always the things that we don't expect that turn out to be the most intriguing. So who knows what we'll find in the interior.
Follow up to that, is there any way to tell either from aerial view or a mission like this, maybe in a different area, if there is a previously active subduction zone or any of those other things, or can you tell even where any of the transform faults are? People had proposed that there might have been subduction and transform. We do see evidence for transform faults from the high resolution topography data that we have. And in the past, people had proposed that there might be subduction zones on Mars. We think that that's not the leading hypothesis for how the northern plains formed. It was previously proposed as an option for how that low topography in the northern hemisphere formed. We now think it's likely due to the presence of a huge impact early in Mars's history. And we've come to that hypothesis based on the topography, the gravity data, the geology and the faults that we see at the surface. InSight will actually be adding to our knowledge of how these two hemispheres formed. We'll be understanding the thickness of the crust, which we don't know very well at all now. We'll see perhaps if there's a difference in the composition and the thickness. We know there's a thickness difference between the north and south, but getting the exact difference between those two will help us better interpret these hypotheses. And we assume it's going to support the impact theory, but again, we'll find out. Thank you.
All right, we're taking a question right here. Go ahead.
Hello. Steve Gorman from Reuters. So two questions. One, how long, if after the InSight lands, if it arrives safely and settles safely, will it begin to conduct, will the seismometer and the heat probe begin to do its things? And then also just a very specific question about the sensitivity of the seismometer. I believe you said in the past, Dr. Brenner, that it would measure seismic waves as small as the diameter or half the diameter or half the radius of a hydrogen atom. Could you give me that one more time?
Yeah, that's right. I mean, the sensitivity of the seismometer is in acceleration units. Our requirement is 10 to the minus 9 meters per second squared, and if you turn that into displacement, that comes down to less than 10 to the minus 10, which if you, depending on exactly how you define it, it's about half the radius of a hydrogen atom. And that's
radius.
Yes, and we're actually a little bit better than that over part of the frequency band. Thank you very much, Philippe. We're about a factor of 5 better than that in some parts of the frequency. So yes, we're pretty doggone sensitive. And so one of the issues that gives us is that makes us sensitive to everything else that's happening in our environment. You know, if there's a little bit of wind, if the temperature changes a little bit, even if a little pressure front goes by, it's going to change the seismometer around. And so that's why we have a weather station on board, which we haven't talked about much today because it's not part of our core mission, but we have a very competent weather station. It's going to give us temperature, wind, and barometric pressure 24 and a half hours a day, every day on Mars. And so in addition to doing all this science about the deep interior of Mars, we're actually going to be contributing a lot to understanding the surface environment of Mars as well. And okay, so in terms of how long it's going to take to get the instruments going, InSight's kind of a laid-back, slow-motion mission compared to a lot of things that we've done before. We have a 2-year mission to do our science, and so to get that mission started, we have to get our instruments on the ground. It's going to take us about probably 2 or 3 months at least to get our instruments down, and that's because we have to do a survey of the area in front of the spacecraft, make sure that we don't put the instruments down on a rock or in a hole or something like that, and then we're very, very very careful about how we put the instruments down. You saw the animation that they had the robotic arm going and picking up the instruments and putting them down. It actually goes a lot more slowly than that, and we have a whole set of activities that we go through to ensure that when we put those instruments on the ground, they're going to be in a place where they can operate properly and get these kinds of measurements. So it's going to take us, probably a month or 2 to get the seismometer down, and another month or so to get the heat flow probe down and penetrating down into the surface. So whereas we're going to get some photos and some preliminary data back before that, in order to really get operating, we're probably looking at early next spring when we're really going to start bringing back that kind of science from Mars.
Thank you.
Okay, we're going to turn it over to the social media team to tell us some of the questions that have been sent in.
Well, Bruce anticipated one of the hottest questions out there that everyone was asking us, how long until we get the data? And you mentioned the cameras. Desvain on Twitter asked, does InSight take pictures? And if so, will we be able to see them?
It does take pictures, and you will definitely be able to see them. We have 2 cameras on board. We have one's called our instrument context camera, and that's going to take a picture just a few minutes after landing. And it's bolted to the bottom of our deck, and it has a fisheye view, so it's going to show about 120 degrees, 130 degrees of view just right in front of the lander, perhaps even up a little bit above the horizon, down to very close down to the spacecraft. And that shows the entire area that we're going to be trying to map out to deploy our instruments on. Then we also have another camera. It's actually attached to the robotic arm. It's a higher resolution camera, and we use the arm itself to point that camera, and we're going to be able to put together mosaics of both the area in front of the spacecraft and the entire region around the spacecraft. And those images are going to go out onto the internet more or less right away as soon as we get them. So we'll have raw images out on the internet for people to look at as the mission progresses.
Fantastic. Okay, so Winter in our YouTube chat wants to know, how will the InSight seismometer be able to map the internal structure of Mars in 3D with just one sensor? How is that accomplished? And Rabbi Cooper over on Twitter follows up, don't we need 2 or 3 to determine the inner composition?
You would think, wouldn't you? Usually if anybody knows anything about seismology, you know that you need at least 3 seismometers to do seismology. And that's true unless you get really clever about it. So we had to get clever. I mean, we actually had lots of concepts of missions that had 3 landers, 4 landers. We even had a concept with 18 landers on Mars at one time. And none of those actually ever got funded because they were very expensive. And so we had to go back to the drawing board and figure out, well, how can you do seismology, real quantitative seismology with a single seismometer? And it turns out there are quite a few techniques that are available to us. I mean, and people have used this on the Earth, but they get sort of eclipsed by the sort of array seismology that we normally do. And one of the things we do on Mars is we use the fact that Mars is small to our advantage. And what happens is that in addition to the P waves and the S waves that you normally hear about in seismology, there's also something called a surface wave, and that's a separate kind of wave that travels along the surface of the planet. And so, in addition to the P and the S wave, we actually get the surface wave, which travels to the seismometer, and there's another one that goes the other way around the planet and comes in the long way. And so there's two extra what we call arrivals. And then finally, the one that's gone all the way around the planet can go around again and hit our seismometer. And these things can keep going around. They get a little bit smaller and smaller each time, obviously. So we use that extra information to be able to figure out how far away the Mars quake is. And we can actually use what's called polarization analysis to figure out which direction it's coming from. And so instead of having to triangulate on it using multiple seismometers, we're actually able to use sort of the extra information that's contained sort of later on in the seismogram in order to get the distance and the direction. And it gets more complicated than that, but that's sort of the basic method.
We've got a mountain of questions, Veronica. How much time do we have?
I think we're good. Go one more, and then I'll do a final look in the room here to see if there's other questions. Go ahead.
Okay. Well, two-parter. Okay. Oscar wants to know, is there an opportunity for citizen science to participate with this mission?
Well, we will be putting the seismic data out on the internet within a few months after acquisition. If you're a citizen seismologist, you can certainly work on it. We'll also be putting the images out, and there's a very vigorous community of photo interpreters out there that have been doing photo interpretation on Mars images for many, many years, and our images will be available for that as well. We also have something called seismometers in the schools, and we're actually going to be sending the seismic data out to schools which are participating in our program at the same time, basically, that our scientists and our team are going to get it. And so the students at various middle schools and high schools are going to be our data in close to real time, and they'll be able to try their own interpretations on it and so forth. And we're hoping that they don't beat us to the punch in any of the big discoveries, but we'll see what happens.
And additionally, we have a Mars Weather Service. So you can get information about the weather daily at our site. You can get wind, atmospheric temperature, surface temperature. So you'll also get a daily weather report from our site.
Okay, let me ask one more time out here in the audience. Yes, we do have a question here. We'll get you a microphone. Okay.
Scott Sutherland from the Weather Network. I'm really interested in knowing about the weather on Mars. So this, as far as I understand, is the very first continuous weather monitor that we've put on Mars. Previous missions have had weather, but it's very distinct measurements every day. This is going to be, as you said, 24 and a half hours every day. Do you anticipate learning anything really new about Mars weather that we didn't know about before?
The short answer is yes. I don't know what it is. We'll have to discover it. But yes, I mean, every time we go to a planet and look at something differently with a different set of instruments in a different way, we always discover something new. And this is, as you said, this is going to be a unique data set of continuous measurements, temperature, barometric pressure, wind, speed and direction, all day long, all night, over an entire Mars season. And that's obviously going to, I think, just have an enormous wealth of scientific information for us.
Okay, we're going to take one more social media question, and a reminder that if you have sent in a question with hashtag AskNASA, we'll continue to answer those after we go off the air. Go ahead, Stephanie.
All right, so this is for all of our scientists here today. Anna M. on YouTube would like to know, what would be more exciting for you? A result that meets your expectations or something completely unexpected?
That's an easy one. Unexpected is always a lot more fun. Yeah.
I would agree with that.
Yeah. Meeting your expectations is, gives you a nice warm feeling, and then you say, well, what's next? What am I going to do next? If you see something that's unexpected, that always opens up a whole new doorway into something that you never thought of before, and that's what a scientist lives for, really.
Exactly.
Yeah, that's the coolest part. What we don't know now is what is the coolest part.
I was just going to say, that's what we do as explorers, right? That's why we're here. That's why we're doing what we do, is to find those unexpected treasures that are out there, the new discoveries that are going to drive the next mission and send us to the next destination.
Oh, yeah. The root motivation is exactly what they said. I have nothing to add, except perhaps one point to precise that there is a technological things, there is the challenge of the science discovery that we are going to make, and also there was a very interesting thing during all development, and also the following is to work together with different culture, different languages, different money, and it's definitely very interesting that people on Earth are able to work together before we wanted to talk with Martians, for example.
Okay, that concludes our briefing for today. Thank you all so much for spending time here. Thank you, gentlemen, for joining us all the way from Germany. We look forward to having you out here for landing.
I'll be coming on Friday.
Okay. Now, I want to remind you about all the different activities we've got going on up through landing. So to watch our schedule on Sunday, which will be our final mission news conference before landing, and then also that afternoon we have a NASA social program that will also be televised on NASA TV. So we have the news briefing at 10 a.m. Pacific time, 1 p.m. Eastern time, followed by the NASA social event, which again is a great Q&A, another opportunity like this to send in more questions. That will be at 1 p.m. Pacific time, 4 p.m. Eastern time. And then landing day itself, Monday, November 26th. We want you to join us. The landing itself takes place about noon Pacific time, 3 p.m. Eastern. Our commentary begins 1 hour prior to that. And there are multiple ways that you can watch. The easiest way is nasa.gov/live. Bookmark that now so you have it for Monday. You're going to be online Monday anyways for Cyber Monday. You're going to be shopping. Just have that extra screen open. We also have a very good toolkit with a lot of in-depth information about the mission, a lot of fact sheets, and a very good list of multiple ways you can watch. That URL is go.nasa.gov/insight toolkit. There's great tabs there. You want to click on Watch Online. You will get a full list of all the different platforms where you can watch our broadcast, including our 360-degree camera from inside Mission Control. And you will also find on that site a tab that says Watch in Person. That includes a long list of public viewing events across the country. You've got viewing events from here in Los Angeles at Caltech and the California Science Center all the way across the country to New York, in Times Square on the NASDAQ Tower, and all the way into Europe. So please do go to that site if you want to join into a real conversation about landing. Do that, and we look forward to having you back here on Sunday for the news briefing and Monday for landing. And as we go into this Thanksgiving holiday for the in the United States, I just want to wish everyone a very safe and happy Thanksgiving, and thank you again for joining us. We'll see you on Sunday. We're going to play back all the graphics you've seen in the news conference today. Stand by.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Data from space are informing those fighting the California wildfires, a U.S. commercial resupply mission launches to the space station, and showcasing the powerhouse for our Orion spacecraft. A few of the stories to tell you about this week at NASA. Satellites in space have captured imagery and data of wildfires that have continued to plague California, including the Woolsey Fire near Los Angeles and the Camp Fire in Northern California. The Camp Fire, which began November 8th, has become the deadliest wildfire in the state's history. It has also become the most destructive wildfire in California history, with a vast number of structures destroyed by the blaze. Our advanced rapid imaging and analysis team used the satellite data to produce damage maps to help officials and first responders identify heavily damaged areas and allocate resources as needed. On November 17th, our commercial partner Northrop Grumman launched its Cygnus cargo spacecraft to the International Space Station on the company's 10th commercial resupply mission for NASA. The Cygnus, dubbed the SS John Young in honor of the late astronaut, launched from our Wallops Flight Facility in Virginia with about 7,400 pounds of research, crew supplies, and hardware for the crew aboard the orbiting outpost. A November 16th event at our Kennedy Space Center in Florida showcased the recently arrived European service module for our Orion spacecraft, which is provided by ESA, the European Space Agency, and highlighted our history of cooperation and collaboration with ESA for deep space exploration.
This is a momentous occasion where we're going to have the opportunity to fly into deep space, and the European service module is a huge element of this architecture.
The service module will power, propel, and cool Orion on Exploration Mission 1, its first uncrewed flight test with our Space Launch System rocket. The first group of restored historic mission control consoles, which helped land humans on the moon, arrived recently at Houston's Ellington Field near our Johnson Space Center and were unveiled before Apollo alumni, NASA personnel, and media. This event marks a major milestone in the ongoing restoration of historic mission control, a National Historic Landmark, and its preservation for future explorers. Expedition 58, the International Space Station's next crew, conducted final qualification training in Russia in preparation for its flight to orbit. Our Anne McLean, Oleg Kononenko of Roscosmos, and David St. Jacques of the Canadian Space Agency are targeted for launch December 3rd for a 6-month mission on the station. We began research flights off the coast of Galveston, Texas in support of the Quiet Supersonic Flights 2018 series. The project uses FA-18 aircraft flying at supersonic speeds to test community response to the quiet thump technique designed to reduce loud sonic booms typically associated with supersonic flight. The X-59 quiet supersonic technology X-plane we are developing will be able to demonstrate quiet supersonic technologies in straight and level flight over a larger area than the FA-18. That's what's up this week at NASA. For more on these and other stories, follow us on the web at nasa.gov/twan.
Station, this is Houston. Are you ready for the event?
Houston Station, I am ready for the event.
University Prep Charter High School, this is Mission Control Houston. Please call station for a voice check.
Station, this is University Prep Charter High School. How do you hear me?
University Prep Charter High School, I have you loud and clear. Welcome to the International Space Station.
Thank you. Good morning, Dr. Anand Chancellor. My name is Mr. Sherfano. I'm a special education mathematics teacher here at University Prep Charter High School in the Bronx. Welcome to our school and welcome to the greatest borough of New York City. Our students have been grappling with the possibilities of colonizing Mars, and they have some questions for you to aid their research and potentially draw some conclusions.
Nick, thanks so much. I definitely want to give a shout out from my previous expedition crewmate, Ricky Arnold, and his daughter, Carrie. They want me to tell you hello, and Ricky just returned to Earth not that long ago, and also says greetings. Ready for that first question.
Why have the moon and Mars been a primary focus for NASA as our next goal in space exploration?
Well, I'll tell you, I honestly see these parts of space exploration as stepping stones, starting, of course, here at the International Space Station, and then on to the moon and to Mars. And the way you got to think about it is, Mars is an awfully long way off. And so what we've been doing here in low Earth orbit certainly is developing new technologies to make sure that we can sustain ourselves on board a space station for long periods of time. The next step after that would be to try and get to the moon, a place that's not too far away from Earth, where we can continue to test these technologies and even develop a lunar habitat where people can live and work for even longer periods of time. And then after that, once that is established and we're pretty sure about the direction we're headed, then when we know the engineering is sound, we head off for Mars. So I really look at the moon as almost a practice ground, and it is much more than that for sure. But it is a tremendous place that is very close to Earth, where we can continue to develop robust technologies for us to even get to Mars. Because even every day on board the space station, things break. Technology that we think might work maybe only lasts a couple months, and we've got to revamp and figure out how to make things work better.
What role will commercial partners play in the exploration of the moon and Mars?
So it's important to know that right now, NASA works very tightly with its commercial partners. We have commercial cargo vehicles coming up and down all the time. In fact, we've got the Northrop Grumman vehicle that is slated for launch tomorrow. We just released an HTV cargo vehicle not that long ago. Many companies have been working with us every day to help bring cargo safely to and from the station. And very soon, we're going to be bringing people to and from the space station with some of our commercial partners. And I think a lot of folks believe that we work completely separately, but that's not the case. We've got thousands of folks at NASA and thousands of folks at those companies working together to make sure things go well. And I foresee those partnerships continuing as we go to the moon and Mars. There's not going to be one agency across the planet that is going to be able to make this journey alone. We do it in partnership. So I really foresee our country working with multiple other countries as well as multiple companies, both nationally and internationally, to make that mission successful.
What type of experiments are you conducting on the International Space Station that could help send humans deeper into space?
So I think some of the biggest things we do on a daily basis here is really creation of water. So, and what I mean by that is we don't fly all the water that we use up here in the space station. We reclaim as much water from our own station atmosphere, and we even recycle our own urine to create water for the next day's coffee. So just technology like that is extremely important when you think about long duration or expedition class missions, because water is the key to life. What about food? Well, right now we're growing vegetables here on the space station. We're growing some kale and some lettuce. And it's a little different up here because water acts differently due to surface tension forces. So we're learning right now the best way for plants to grow, the best way to water. What sort of nutrients do we need? Do we need soil, or can we use other nutrients for the plants to grow? And we're doing it on a small scale up here, but we've already proven that we can successfully grow crops. So when we set off for Mars, or we set off for that habitat, we can't carry all our food with us. We're going to have those technologies already developed so we can begin to grow those crops on the way there so that they're ready.
Being that astronauts on the International Space Station are from various countries, how do language barriers play a role in the operations of the station?
Yeah, it's funny. So we actually don't see language as a barrier up here. Now, all of us, we get training in the Russian language, and our Russian cosmonauts get training in the English language, and we go back and forth. In fact, if you were to come up to the space station and just listen to one of our daily conversations, you would hear us go back and forth. And very often, I will talk to Sergei in Russian, and he will answer me in English. And sometimes our sentences are mixed, kind of a Wranglish, if you will. And we kind of see it as an advantage or a benefit, because sometimes the words are better in the Russian language than they are in the English language, and we choose to use those. And so it's a lot of fun because it also gives us a better opportunity to discuss important things like family and our loved ones at home with our counterparts. So I think if you talk to most astronauts, we really don't see that as a barrier at all. It makes our lives more fun up here.
How has your training as a medical doctor helped you and the crew on the International Space Station?
So certainly, as a doctor, I'm prepared to handle any sort of medical event should that arise. Honestly, where I felt it's come more into play is by looking at a lot of the science up here. And the number one science experiment that's going on up here is yours truly and my other crewmates, Alex and Sergei. So really studying the human body and what happens to the human body in space is fascinating, because once we get up here, the moment we get into microgravity, we have this massive fluid shift that occurs, and our heads and our faces look a little puffier than they do on the ground. Believe it or not, our bones and our muscles begin to break down almost immediately, and we have to actively work to counter that every day. The cool thing that happens is you don't get that same rush of blood to your head when you go upside down. So I can talk to you guys on the ceiling. I can talk to you guys on any wall. It doesn't matter. It doesn't affect me. So it really, my brain almost remodels itself to work in this environment. And so I've found that being a physician, it just has expanded my knowledge of how wonderfully adaptable the human body is. It can adapt to any environment in any condition.
What are some examples of how astronauts use mathematics on the International Space Station?
Yeah, so it's funny. We use math in many different ways, both indirectly and directly. Something as simple as, the other day, Alex, my crewmate, and I, we were looking at some medical devices and actually calculating the volume in the tube to figure out how much fluid could be held, because fluids do act differently up here in microgravity. So we use mathematics for that. And if you look at the station itself, orbital mechanics is mathematics. The way our robot arm maneuvers, the way the joint angles are calculated, that's all mathematics. So mathematics is really the key of life to the space station. And a lot of times we don't see it directly as the astronaut, but it keeps all these systems running up here.
How does the International Space Station replenish its supply of water and oxygen?
Yeah, so water itself, we kind of like I talked about, we have a water recovery system where we reclaim everything from the atmosphere. And so even from our urine that we turn into tomorrow's coffee, sweat, the condensate from my breath, all that is reclaimed from the system. Now, oxygen itself is created through our oxygen generation system through electrolysis of water. And so it's really a neat system that we have up here. It was very interesting to me because I had the opportunity to travel to Antarctica about 8 years ago. And I realized very quickly that when we were living on the ice, our main concern every day was something we called water balance, and that's what we called it. How much water did we have for people to drink? How much water did we have for daily operations? Did we have to go out and chip the ice to melt the ice to make the water? Up here, it is very much the same. The great part is we have some tremendous folks on the ground always looking at that water balance. Like I said, water's the key to life, and so we are always looking at what we may need to add to the system or take away to make sure that the station is in balance at all times.
How does the research aboard the International Space Station and space exploration benefit human life on Earth?
Great question. I didn't realize until I got up here some of the experiments I would be doing. We don't get training necessarily on the ground. Sometimes we learn about them once we come up here. There was some tremendous cancer therapy research we did early in the mission, and it turns out that some of the cells that live in your body, that live in your blood vessels, really like to grow in microgravity. They don't grow the same way on Earth. They don't live for very long, but up here in space, they grow really well, and it lets scientists test different chemotherapy agents. Northrop Grumman 10, our Cygnus vehicle that hopefully, knock on wood, will launch tomorrow, is bringing a really cool medical experiment up looking at Parkinson's disease, and it's looking at a very specific protein. And the reason those scientists want to study that protein up here in space is because when protein crystals grow up here in space, they're much better structured and much better ordered. And what scientists want to know is how to create different drugs to target that protein for Parkinson's disease. And they haven't been able to do that very well on the Earth because it doesn't grow very well. But up here in space, it grows really, really well. And so even as a physician, you'd think I'd know about all these experiments beforehand, but it has been super cool to see these things come up on vehicles and let us test them directly.
If given the opportunity, would you yourself volunteer to be among the first to go to Mars?
So I've had a lot of questions about what I plan to do after we're done and undock and land. Honestly, I have to be honest that I'm totally focused on this mission right now. We still have a long way to go before we're ready to get to Mars, but I feel like my job right now on board the station, besides the fantastic science I've told you guys about, is to help prove that humans do a really good job living up here, that we can get through almost any problem, knock on wood, that we're prepared to spend long duration periods of time up here, and those get longer and longer every year. We've already had Scott Kelly stay almost up here for almost a year, Peggy Whitson, and I think that by just our presence being up here shows that humans can live successfully in low Earth orbit, and that is going to translate for when we get to Mars.
In addition to sending humans to the moon and Mars, what are some other long-term goals for NASA?
So one thing I want people to understand, and it's a fantastic question, because not only do we have to send humans to the moon and Mars, we have to send them successfully and with all the tools in place. We've already learned that in space that the human body is remarkably adaptable. Moon and Mars are a little different story. Obviously, there'll be more radiation on the moon and even more radiation in the transit trip out to Mars. So we've got to think about that problem. We've got some great technology on board the space station that we use. Like I talked about, the oxygen generation system. Are those same technologies going to work on the moon and the Mars? And so I think part of NASA's job right now is certainly getting us out there, but what people forget is it's not just the end goal that we're looking at. All that technology that we develop along the way, like when we got up here and we learned that the body's cells love to grow up here, and that helps us cure cancer. That is something that we learned on this journey to get to Mars that benefits people right now. And so that's kind of what I focus on as well. I mean, NASA has so many goals out there, from human science to earth science to exploration science. But I don't want people to forget that everything we've learned along that journey, and I really consider us only a little bit of the way on that journey because we don't know where that journey is going to end. We have learned so much, and it's already benefited folks back on Earth.
In what ways has technology aboard the International Space Station been able to simulate life on Earth and space?
Yeah, so I wanted to ask about this question. So are you asking, are we able to kind of recreate Earth on board the space station a little bit?
Yes.
Yeah, that would be, so of course you've probably seen movies where they're able to have these earth rooms and you can go inside and feel like you're in the forest or at the ocean, and we don't have that up here. We have small ways that help us remember and recreate life on Earth. Something as simple as movie night, where we put up our movie screen and we have a film projector and we have movie candy and the crew gets together. For us, that's our theater. That's how we recreate Earth. You'll spend a lot of crew members, though, in the cupola during the day looking back on their planet, because just having your planet in sight and in view, being able to see the first snow, being able to see, unfortunately, we've been looking at all the fires occurring in California. And so for us, that makes us feel closer to our home planet. I hope someday virtual reality does come in and we're able to recreate these tremendous virtual reality rooms where you actually feel like you're there. We're not there yet, but we're getting there.
How do exercise routines differ from person to person aboard the International Space Station?
So the specifics of the exercise routine definitely differs from person to person. We have a person on the ground, they're called our ACER, and those are the folks that look after us while we are up here. And we essentially get exercise prescriptions, just like you get a prescription from a doctor's office. And depending on your height, your weight, and your strength level, they will alter that prescription for you. Now, that being said, every astronaut every day exercises anywhere from 2 to 2.5 hours. We get 1 hour of aerobic activity, which is either on our treadmill or our exercise bike, and we get 1 to 1.5 hours on our weight machine. And you may think, well, how do weights work in space? I mean, weights don't weigh anything, so how do you generate load? Well, we do that with special vacuum tubes, and we can generate up to almost 600 pounds. So you can name the lift: squats, deadlifts, bench press, shoulder press. We can do it up here, and we do it every day, because that's one of those main countermeasures I talked about to prevent that loss of bone and muscle while we're up here.
Why is human space exploration worth the risk?
That's a very big question. I think you will get different answers from different people. Part of my answer, my personal answer, kind of harkens back to what I talked about just a few minutes ago, and that's what you learn along the way. Certainly as humans, we are not a stagnant species. We are not meant to stay in one place. We have explored this planet from the very beginnings of time, and will continue to explore. And what you learn along the way, what you've developed along the way, is what really brings a tremendous amount of benefit back to Earth at that time. So we continually have people that push boundaries and ask what's possible and what's not possible. And by pushing those boundaries of what's possible, new inventions, new experiments pop out that we had no idea existed. And so a lot of the technology that's used on Earth right now, even mammogram technology, is stuff that was invented by the space program as we pushed to get this orbiting laboratory in place. And so it's worth the risk because of everything we gain along the way. And again, I don't want people to think that all the gain comes right at the end. I'd say the majority of the gain comes right along that journey until we get there.
What animals would have the greatest likelihood of surviving on the ISS with humans?
Well, I wish I had my 2 dogs up here because I do miss them quite a bit. But certainly we have had animals on board the space station. We've had mice who have done quite well. We've had bees. We've had spiders. It was very interesting to study the mice because you watch them initially float. And when we get up here to the space station for the first time, we are not very graceful. We're holding on to everything tightly. We don't know how to use our feet. It's not natural for us to flip our feet up onto multiple walls and work in different directions. It's very, very uncomfortable. But now that I've been up here for almost 6 months, this is very comfortable. Again, I can work on any surface. The mice were the same way. At first, you saw them flail about a bit, but then become very, very comfortable with their surroundings and float very gracefully. So I think any creature, once they get up here, would learn to do very, very well. That being said, the animals that I mentioned are the only ones we've had up on board ISS so far.
Dr. Anand Chancellor, this is Principal D'Amato, and I would just like to, on behalf of our student body and our staff and our school community, thank you wholeheartedly for taking your time to speak with us today. It's been so inspiring and educational, and I know that you've made a real impact in these young people's lives. So at UPCHS, one way that we like to show our appreciation is by doing a bit of a cheer. So If you'll bear with us, we are. We are. We are. Thank you so much.
Thanks so much, University Prep Charter School. It's been awesome.
Station, this is Houston ACR. That concludes the event.
Thank you to all participants from the University Prep Charter High School and Station. We are now resuming operational audio content.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Good morning. It's Tuesday, November 20th, 2018, which means today is the 20th anniversary of the International Space Station. I'm Leah Cheshire, and this is Dan Hewitt. And in just a few moments, we'll be speaking live with the crew on board the space station. We want to ask your questions, so comment below or send us a tweet with the hashtag SpaceStation20th, and we'll relay your questions to the crew.
But first, let's take a little walk down memory lane. Again, it is the 20th anniversary now. So 20 years ago, on November 20th, 1998, the first element of the International Space Station launched. It took off from Baikonur, Kazakhstan, atop a Proton rocket, taking only about 10 minutes to ride all the way up into its preliminary orbit. So that first piece of the International Space Station heading into space. And that would lay the foundation for one of the most complex international engineering projects in history. And now this was something, it was the culmination of work that was done for years and years by 5 different space agencies representing 15 different nations coming together for, again, one of the most complex tasks ever undertaken. And after that 10-minute ride and the first element, Zarya, the module that still consists on board the space station today, was in orbit, it was not alone for long. Less than 2 weeks later, a space shuttle mission flew into orbit with the next module to get added on board and got the first pictures from space of the International Space Station. It arrived with the Unity module, which would consist of the first piece of the US segment on the station, and kicked off what would be dozens of launches over many years to build the International Space Station piece by piece by piece. Now, these missions brought up all of these different components, building from that first tiny piece to a sprawling space station the size of a football field that we now have today. It brought up everything from new pressurized modules for the crew members to live in, giant solar arrays, the large truss structure which forms the backbone of the space station, new spaces for the crew members to live and work, to conduct research, to do spacewalks, all of these different activities that we now see every day on board the space station. And it was serviced by different cargo vehicles from all around the globe, all of the different space agencies sending these vehicles, and in the recent years, US commercial companies also sending stuff on board. And it's been inhabited now by people every single day since November of 2000. And since then, over 230 people have lived and worked on board the International Space Station, coming from 18 different countries. Using the space inside the space station, which right now is about the size of a 747, their missions lasted anywhere from just a couple of days to close to a year, as we had with the one-year mission with Scott Kelly and Mikhail Kornienko just a short time ago. But it wasn't just the people on the space station, it was also teams working all around the globe in mission control centers, in training facilities, getting these crews ready and working hand in hand every single day. And of course, the main reason we have a space station is to do research and to develop new technologies as we begin to explore farther out into the space, not only around our planet, but well beyond. Over 2,500 different experiments from 106 countries have since been conducted on board the International Space Station, pushing the boundaries and fields of science everywhere from the physical, combustion, to biology, just learning how to live and work in space for extremely long periods of time. And then, of course, new research coming from commercial companies, academia, and other government agencies through the U.S. National Lab. So a lot of exciting opportunities already taking place on board the space station in the last 20 years, and a lot of very exciting ones to come.
We currently have 3 people on board the space station: European astronaut Alexander Gerst, NASA astronaut Serena Auñón-Chancellor, and Roscosmos cosmonaut Sergei Prokopyev. We're going to be standing by and waiting for a call with the crew on board the International Space Station, so don't forget to submit your questions so we can ask them live.
That's right, we'll be getting that call in just about 30 seconds. These 3 have been on board the International Space Station since June earlier this year, and they're going to stay on board until later in December when they come home on December 20th. So we'll stand by now. We should be hearing from the Capcom and Mission Control momentarily.
10 seconds out.
you know what you're going to say.
Station, this is Houston. Are you ready for the event?
Houston, this is the International Space Station. We are ready for the event.
JSC PAO, this is Mission Control Houston. Please call station for a voice check.
Station, this is JSC PAO. How do you hear me?
Johnson Space Center, this is the International Space Station. We hear you loud and clear.
Thank you so much for joining us today. We are so excited to celebrate the 20th anniversary of the International Space Station with you, and I think that you three have the best seat in the house. We are going to be sharing some questions that we're taking live from viewers, and the first one is for Sergey. The question for Sergey is, how is the hardware holding up after 20 years, and are there any surprises in how well or how poorly some things have aged?
Первый вопрос для Сергея. Насколько успешно выдержало оборудование и приборы 20 лет эксплуатации на борту МКС? Были ли какие-нибудь сюрпризы с неожиданно хрупким или, наоборот, выносливым железом?
Thank you for question. За 20 лет эксплуатации здесь очень много что поменялось. Можно сказать, осталась только оболочка, все остальное оборудование постоянно производится замена, либо его усовершенствование. Поэтому трудно сказать, что станция 20 лет назад была такой же, как сейчас. И надо сказать, что сейчас очень высокотехнологичное оборудование находится в обоих сегментах, что в российском, что в американском. И мы понимаем, что вот эти все совершенствования, они будут дальше продолжаться, и мы только надеемся, что все будет лучше и лучше происходить. Насчет хрупости этого оборудования, которое здесь находится, естественно, есть вещи, за которыми мы следим очень бережно. Есть определенные клапаны, которые требуют к себе особого внимания, потому что это безопасность станции. Мы за этим очень сильно следим и относимся к этому очень бережно. Поэтому станция 20 лет работает и, надеюсь, еще проработает как минимум 15, а может и больше.
Hello, good to hear you. So yes, in 20 years, a lot has changed on board the ISS. I would say that only the casing has remained the same. The hardware inside has changed and improved, so it's hard to say that the station is the same now as it was 20 years ago. In terms of the technology, it's getting better and better. The quality is improving with each year, both on the USOS and on the Russian segment. And so we hope that it will just continue getting better with the years. In terms of any surprises, yes, there is a lot of fragile hardware on station, and we keep a close eye on that hardware. For example, some of the valves, we monitor them carefully because that affects the station safety. So for 20 years, the station has been great, and we hope that it flies just as well for at least another 15.
All right, our next question came in from Athathon. This is for Alex, and it was, what advice would you give to any future explorers who want to be kind of floating where you are right now?
I think the person who asked that question is already on a very good track because they're already participating in an event at the Johnson Space Center, so they're around in the community. And you are obviously a very curious person, otherwise you wouldn't be there. So those are already two really, really good starting points. I think what helped me was going through life with open eyes, very curious, and I didn't take no for an answer for many of my undertakings. Like if things got tough, I still tried to get to an answer if I was looking for one. If people didn't find an answer, I tried to find out myself. And also, I looked for opportunities to get, well, a little bit closer to one of my dreams. I had a lot when I was a child. I wanted to become a scientist, a firefighter, a train driver, and an astronaut. So I checked off several of these before becoming an astronaut. And every time I saw an opportunity in life, I gave it a chance. I didn't say, oh, maybe next week would be better. Maybe the chance will come again. Well, often they don't. So that would be one of my main advice points. And then Yeah, I guess, not every dream can become real, but you got to give it a chance, right? And because if you don't, it will never become real. And then I was one of the most surprised people when eventually I became an astronaut, because I always thought, oh, astronauts are superheroes and they can do all much better than I can do. Well, guess what? We're just normal people, and I just needed to learn that, to understand that everybody of you down there can do something better than anybody else around you, and if you use that talent, well, it might bring you here. A boy or girl, doesn't matter. You just give it a try.
Thank you. Our next question is for Serena from J.R. Kraft, who wants to know what you think the next 20 years of humans in low Earth orbit will entail.
Wow, that's a big question. Certainly to start with, we've had a lot of science going on in this orbiting laboratory for some time, and our science capabilities continue to increase. In fact, just a couple weeks ago, Alex and I installed the Life Sciences Glove Box, which pretty much doubled a lot of our capability in some areas. And I think scientists are just learning what this microgravity environment can do for their research. We've discovered that cells act differently, proteins act differently, they grow differently, the structure is different. And it helps them with their research in things like cures for cancer, cures against Parkinson's disease. And so this has been really exciting on this front, because this is right now is really the first time we're beginning to see some of this, and we realized that we could utilize this station for another 8 to 10 to 20 years as far as science is concerned. As far as humans living in low Earth orbit, we learn new things almost every month, every year. Humans react differently. We're all different. And so it's a constant challenge to see how long can we keep the human healthy up here. We do a very good job, and I think the human body does an amazing job of adapting to the microgravity environment. But certainly, I think these next 20 years, they're going to go by in a flash, because even for us, our 6 months have gone by very, very quickly, and we're continuing to learn new things every day.
All right, we also collected a couple of questions on YouTube, and this one from Ellie is for Sergey.
How do you celebrate holidays on the space station?
Вопрос Сергею. Как вы отмечаете праздники на МКС?
Thank you for question. Мы отмечаем в первую очередь тем, что вот сейчас находимся рядом перед вами и отвечаем на ваши вопросы. Это очень приятно, что мы имеем возможность встречаться с теми людьми, которым это очень интересно. И, конечно же, мы будем вечером отметим за совместным ужином. У нас пришло 2 грузовика с подарками от семей, от наших друзей. У нас есть свежие фрукты. Мы обязательно попробуем все эти подарки, и это будет для нас определенным праздником тоже.
Thank you. That's a great question.
Dinner with candle.
And actually, we are celebrating today our 20th anniversary. And the first way we're doing that is by speaking with you who are interested in what we're doing. And it's a great delight for us. And it's a great way for us to celebrate together with you. This evening, we're going to have a joint dinner. We've had 2 new cargo vehicles arrive. They've brought up gifts from friends and family and a lot of fresh fruit. And we look forward to trying out all those gifts and to celebrate in the evening also. And we're celebrating with this great candle that you see floating around.
Well, we hope you really enjoy your celebration. We now have another YouTube question for Serena, and this comes to us from a group of students in California.
Hi, we are a 5th grade Lego robotics team from San Jose, California. Congratulations on the 20th anniversary of the ISS. We have heard that many astronauts have nail injuries during spacewalks. Our team is working on a project to solve this problem. Have you or your fellow astronauts faced nail delamination during an EVA? Do you use any cream or lubricant inside the EVA space glove?
Thank you for taking the time to talk to us. You inspire us, and good luck on your mission.
Hey, that's a great question. Actually, the nail bed delamination is something that we've seen medically for a long period of time. Not every astronaut gets it during an EVA. It's variable, and we really can't predict who gets it and who doesn't. We think some of the contributing factors are that we are working in a pressurized glove. So when we go outside to do a spacewalk, that entire spacesuit is pressurized to 4.3 psi. So space is at vacuum, and we, of course, have to be above that to survive. But that means every time you close and open your hand in a spacesuit, you are working against that pressure. And every time you hold on to a handrail and move around the space station, the ends of your fingers also strike the ends of the gloves sometimes. And so we think that plus just pressure around the end of the finger sometimes causes that nail bed to lift up. So we're not allowed to really use creams or ointments inside the suit because we're working in a 100% oxygen environment, and that could be dangerous for us. There are certain sorts of substances that are approved, but very few, and some astronauts do use those, but it is kind of a mystery. Now, sometimes we see this pop up in training, and if that's the case, we can custom make gloves for that astronaut, and that seems to do the trick.
All right, this next one is for Alex, which we're getting a lot of happy birthday ISS wishes from Berlin and a couple of other places in Germany. This one comes from Angela, who wanted to know, what do you miss most from Earth while you're up there?
Yeah, hey, Angela. As always, you know, when you're in a place where you don't have some of the things that you like, then you miss them first, right? Those are the things that you might miss from Earth. Is like food, like really great food. I miss, for example, salad, or also sometimes taking a shower just to have the feeling of water running down my body. I didn't have that since half a year, even though we wash ourselves with water, but it just doesn't fall down. Things like that. And then there's the things that I miss that I wasn't aware before, that all of a sudden hit me when I was up here, that I was missing things that I didn't even know they were important to me. For example, a November rain. Like some people think it's a fall rain. It's like cold and dirty outside, but actually, you know, when you haven't had rain, a single drop of rain for half a year, you start missing it. I start missing weather. I start missing nature around me, just like a walk in the forest, smelling the leaves, smelling the greens outside. That is something that I really miss, and I think that's something teaching us when we look down on Earth, right up here in space. I always thought when I grew up, space was a special place. I always wanted to be there, and I thought, well, Earth is so normal and space is so special. Well, when you're up here, you realize it's exactly the opposite. It's the other way around. Space is pretty much everywhere around us, around this little planet. It's black and empty. There's a few points that are worth looking at, and we do that, like the planets around us. But actually, the real special place in the universe, the real unique place that is our spaceship that only exists once and that we have to really take care of because it's very fragile, that's that planet Earth down there where you guys are.
We have another question for Sergey from Miss Anna's students, and they are actually in Serbia. They want to know if astronauts can choose their daily menu, or is what they eat already planned in advance? And do you all eat the same thing?
Вот еще один вопрос Сергею от студентов класса мисс Анны из Сербии. Вопрос про меню. Вы можете сами выбирать свое меню каждый день, или это уже все заранее запланировано? И все ли едят то же самое, или у всех разный план еды?
Thank you. Very good question. У нас есть определенный набор продуктов, который мы должны съесть за 16 дней. Что есть в определенный день, такого правила нету. Вернее, оно есть, но его, в принципе, никто не соблюдает. Мы все равно делимся с друг другом продуктами. Кому-то нравится одно, кому-то нравится другое. Поэтому жесткого меню у нас как такового нету. Особенно, когда приходят вот такие грузовики, как сейчас, мы можем разбавить свое рутинное, скажем так, меню на более интересные вещи, которые присылают нам с такими грузовиками. Спасибо.
That's a great question. What we do have is a set of food items that must be eaten within 16 days. But we don't have a hard set rule about what to eat each day. Well, actually we do, but we don't really stick to it. The truth is that some people like some things, other people like other things, and so we always share and exchange the foods that we have, but we don't have a mandatory menu. And especially it's exciting when a cargo vehicle arrives, like it's happening now, because then we can change up our routine and have some of the special food items that come up only once in a while.
All right, we have one more video that we collected on YouTube. This one's from Trudy in Germany for Alex.
Hello, Alexander, Gerstine, and Sergey. My name is Trudy. I'm from Germany. I want to know why these numbers are mirrored. Happy birthday, ISS!
Hey, Trudy. That's a really good question. And, you know, I was actually thinking about this a few days back. And I realized that I work with those spacesuits so much that I had actually forgotten if the writing was the right way around or if it was mirrored. So I went there and looked again. And you're right, it's mirrored. The reason for that is that the writing is meant for the person that's in the suit. So, for example, one of the things that I can change at the front of the suit is the cooling system. So I can change the temperature from low to high. If I'm warm, I just set down the temperature a bit cooler, and then I feel better in the suit. And to read the writing on that, I would have to use my mirror that I have on my wrist. And so in order to read it properly through the mirror, the writing is mirrored from the beginning. So to me, it looks proper, looks right in the mirror. But it's a really good question.
This next question is for Serena. Amanda is watching live and thinks it would be pretty hard to sleep up there. So she wants to know how you deal with that.
Hi, Amanda. Actually, I sleep really well up here. The first couple weeks, it's a little difficult, only because you're used to lying flat in a bed and you feel the bed all around you. And so when I first got up here, we have a special sleeping bag that we kind of attach to the wall in our crew quarters. And our crew quarters is about the size of a telephone booth, not very big. But once you get inside that sleeping bag, you're almost free floating, and it's a little difficult to sleep at first. So I found myself turning in all directions to put my feet up against the wall, my head up against the wall to feel normal like I was on Earth. And then after a couple weeks that passes, and I still put a jacket, a piece of clothing up near my head so I feel like I'm leaning on a pillow, and that's very comfortable for me. Just to pretend that I'm sort of lying on a pillow. We're not really lying. But overall, our crew quarters are very quiet inside. It's very dark. There are no cell phones to wake you up at night. And so we actually sleep very, very well up here.
All right, this next one just came in from Krusty for Alex. He sees everybody kind of passing the ball back and forth. Are your reflexes as fast in space as they are here on Earth?
Yeah, that's actually a really good question. And it comes back to, right, scientists wanting to find out how does the human body behave differently in space? And can we live for long in space, and how does it change? And one of the things, of course, are muscles. I mean, we knew that in early space flight, people come up here, they don't use their muscles much because floating is really easy, right? They can float up and down with almost no force. But our muscles don't like that because they reduce themselves in size and mass, and then we come back weak. So we're dealing with that problem already since many years, and now actually we find a way to really train our muscles effectively up here. So actually we're not losing muscle mass at all. It's like on my last mission I came back and I had 3 kilos of muscle mass more than before. But of course that's not all. There's other effects in our bodies that change, and we're monitoring this. For example, our eyes for some astronauts change a little bit. Our cardiovascular system changes a little bit. And for example, for reflexes and muscles, we even have an experiment up here. It's called myotones, where we test the tonus of our muscles if it changes. So it's all ongoing science, and that's not only helping astronauts, but also people on Earth who have muscle-related diseases like muscle atrophy and various forms of that, who suffer from these diseases. They can benefit from the science that we do up here. In general, my feeling from being up in space for almost a year now on both my missions is that we do have like smaller things that change up here. But my feeling is that overall, and that's pretty amazing, is that the human body is very, very good at adapting to various environments. And one of them is the space environment. I mean, basically spending up here a year without major changes is a pretty good sign that we could spend much more time out there in space. Of course, we need to do research. There might be like little details that we need to look at that might change and that might become important. But overall, my feeling is that living in space is something.
I think we just had a quick handover, but that was pretty much all of our time that we were going to have with the crew on board the International Space Station. So thank you very much to them for talking to us real quickly. It's always great to talk to them and get some questions from you, the viewer, up to them in space. But that'll do it for our Q&A with the crew today.
Thank you so much for joining. Whether you are watching on NASA TV or Facebook Live, you can learn more about the International Space Station by visiting nasa.gov/station. And you can also follow us online at on Facebook at facebook.com/ISS, on Instagram at ISS, or on Twitter at space_station. That wraps up our time for today. We thank you so much for joining us for the 20th anniversary celebration of the International Space Station.
Station, this is Houston ACR.
Thank you, Johnson Space Center. Thank you, Houston. Thanks to everybody who is joining us today. And all the best from the most complex and most valuable and most unlikely machine that humanity has ever built. All the best from ISS.
Station, this is Houston ACR. That concludes the event. Thank you.
Thank you to all the participants on planet Earth and from the Johnson Space Center Public Affairs Office. Station, we are now resuming operational audio communications.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Throughout human history, people have always worked to harness power to better their lives. Early on, our forebears developed rudimentary machines driven by wind, animals, and water to run these devices. These machines were state-of-the-art for their time, but as with all things, new ideas began taking shape that changed the landscape of how power was developed. Eventually, new machines, fueled by gas, steam, diesel, and coal became the norm, and are, to this day, still the primary way we supply our buildings, cars, and overall lives. And the demand is not slowing down. In recent years, power usage has increased exponentially. So